We have done the installation of EKS using EKS CTL. Okay, it takes about 15 minutes to create the new cluster. Yesterday we deleted the cluster. Okay, just few minutes ago I started the installation, means creation of cluster again, and our EKS cluster is running. Okay, so if we do kubectl get nodes, we can see we have two worker nodes running now. Okay, and yesterday we saw how to create a pod. Okay, and after creating a pod, to access the pod we used various methods. One of the method was to go inside the container and try to access the local host. Then again we tried to access it using cluster IP, then node port, and then using load balancer as well. Okay, and we learned about some commands like kubectl get all will give all the details of pod services and all. Okay. So I did this for some practice. I'll just delete it. So by default there won't be any service. Okay, only Kubernetes service will be running, and that is this one. Okay. Now let's continue with our exercise. That is this one. Create pod deployment and service using imperative command. Okay, so we have covered about how to create the pods. Okay, now we'll cover about how to create the deployment. Okay, so I'll first create the deployment. Okay, and then we'll see how is the deployment different than creating only pods. Okay, so what we'll do is, yeah, let's start with this only. I'll create deployment. Okay, so if you see, we do not have anything running now except the Kubernetes service. Using this command, what I'm doing is I'm creating a HTTPD deployment. So the command is HTTPD. What we are creating deployment. So and the name of the deployment is HTTPD deploy. Okay, we'll be using image HTTPD. Okay, and we need two replicas of it. Like, so just press enter and again do kubectl get all. So if you see, as I have written replicas equal to 2, it started creating two pods. Okay, both the pods are running, and we haven't created any new service as of now. This is the default Kubernetes service. But if you see, we have two deployments. Okay, so we created this. Okay, HTTPD deploy using this command. We said use HTTPD image, so it started downloading the HTTPD image from Docker Hub. Okay, and as we said, we need two replicas. It created two pods. Okay, and if you see, there is also a replica set. Okay, which maintains the replica. Okay, so we have already learned about pod. Pod is the smallest deployable unit. It is nothing but a container. Okay, but pod is generally one or group of more containers. Okay, so in this case there are two containers, and now the new term which we will learn is deployment and the replica set. Okay, with replica set, okay, when we said that create two replicas, it is the controller used internally by Kubernetes to maintain the replicas. It we have mentioned desired should be two. Okay, and current two and ready two. That means everything is fine. Due to some reason, if this one goes down, okay, it will check replica set, make sure that always the two pods are always running. Okay, and how is replica set and deployment different? Okay, it is the due to deployment we are able to create the replica set, and in turn the two pods. Okay, generally when we create only pod, okay, we don't have a option to create the replicas and all. Okay, but deployment we can manage multiple things. Okay, so that's the difference. And I'll just share this image. Okay. So yesterday we have seen pod. Pod is the smallest deployable unit. It consists of one or more containers. In this case, we are using HTTPD image here. In example, it is Nginx. Okay, and what is the replica set? It is self-healing, scalable, and maintains the desired state. Okay, so how it is self-healing, we'll see that soon. And what is the deployment? Okay, so we can update and roll back. Okay, so we haven't seen how to update and roll back, but this is possible only using deployment. So deployment contains replica set and replica set contains pod. This is how it shows here. Okay, so if you see deployment, then the replica set and the pod, you will always see all the three combinations. So now onwards we'll create only deployment, we'll not create only pod. We'll create the deployment, automatically the pods will be created. Okay, now we have created this deployment, we want to access it. So one of the method would be go inside any of the pods, okay, and access the default page. So let's try this. I'll take this pod, both are serving the same page. Okay, so kubectl exec -it, okay, --bin bash, just do curl localhost. We know that HTTPD by default runs on port 80. Okay, so curl command is not there, just do apt get update and apt get -y install curl. There is a typo. And when we do curl, we'll get a default page. Okay, so what we have two pods. Okay, both the pods are serving the web page. Okay, default web page. Now will create some other services as well. That is, first let's create, this is about pod, we'll have to know about deployments. Okay, so let's first create a cluster IP. So we have exposed this deployment. Okay, the name of the deployment is httpd deploy. Okay, we are giving a name to the service, httpd deploy CIP, that is cluster IP, and we are exposing it on port 80. The service will be exposed on port 80. Just click on kubectl get all. Okay, we can see one of the service, this one is running. Okay, and this is the IP. Okay, this DevOps VM is not part of the cluster. Okay, only for accessing the cluster we are using DevOps VM, and due to the inside the .cube directory we have a config file which has all the authentication details, so we are able to connect and see. Okay, but this is not the part of cluster, so when I do curl, okay, it will not work. Okay, so pods are part of a cluster, so when we access one of the pod, okay, we will be able to curl that particular IP. So let's go inside the cluster and just do curl localhost will always run. Now try to access the cluster IP. Okay, we are able to access the cluster IP. Let's Now see how to expose it on the node port. And when we say node port, it is the worker node. Kubernetes worker node. Now we have exposed node port as well, just to kubectl get all. We have a node port now, node port service. Okay, and remember, whenever we create a node port, it will automatically create a cluster IP as well. Okay, only one of the port will be open on the worker nodes. And which are the worker nodes? We can get the details using this kubectl get nodes -o wide. Okay, wide will give the more details, that is the IP address. This is the internal IP address, and these are the external ones. Okay, so if I try to access from the container, which is a part of the cluster, we'll be able to access it. So I'm inside the pod. Okay, I'll just do curl. Okay, this will also work. Okay, the cluster IP for the node port, this will also work, and it has opened a port on the node. This is the node, and the port will be always in the range of 30,000 to 32,000. So it has randomly picked 31449. Okay, we are able to access the page. Let's now create the load balancer service as well. Okay, so the load balancer service is also created. Okay, now just do kubectl get all, and we can see a load balancer is attached. Okay, so again we can access from the container the cluster IP, but now from the outside world as well we can access the this external IP, that is load balancer. Okay, let's wait, it will not resolve fast, I guess. It takes some time to propagate the DNS. Okay, so it will not show it. After some time it will load. Okay, so that was all about creating a deployment. Okay, when we create a deployment, replica set will also be created. Okay, and the pods will also be created. And when we create only pod, there won't be any replica set, there won't be any deployment. Okay, so only for testing purpose we can spin up a pod, so that it is in the same network as that of a cluster, and we can run some command for testing and all. But generally we do not directly create a pod. Only for learning purposes we'll create a pod, but in a production environment and in general we create a deployment, and deployment will automatically create a pod. So let's try to refresh it again. Control V. This is the load balancer. Okay, if you see, it says it works. Now I think it will work from our any terminal. We are on the Bastion host, that is DevOps VM, and it shows it works. So load balancer, it works from anywhere. Okay, inside the pod, outside the world, everywhere it is available. Okay. Okay, so this is all about deployment. Now we'll learn how the replica set is maintained. Okay, so now what I'll do, kubectl delete. Okay, I'll try to delete one of the pod. Okay, I'll delete this pod. So if you see, there were two pods. One is ending with 17 and other one is ending with PB. Now let's check it. Okay, if you see, still there are two pods. One of them is recreated. Okay, 10 seconds ago. So replica set, what it does, it tries to maintain the replicas. When we deleted one of the pod, okay, it automatically created the another one. Okay, this is the self-healing feature of Kubernetes. Okay, that's why it is so powerful. Now when I create only only the pod, okay, let's see what happens when we create a pod and delete it. Okay, so we'll create only a pod, httpd pod. Okay, don't think the name will create issue. Okay, so now it created only the pod, kubectl get all. I'm creating only the pod now. Okay, this is the pod. Okay, we won't try to access it, but let's see what happens when I delete it. Kubectl delete pod. Okay, so this is the standalone pod. We did not create it using deployment and all, or using any replica set. And see, once deleted, it won't come back because it is not part of a deployment or a replica set. Okay. But if I delete any of the pod which is created using this HTTPD deployment, it will be recreated. And it does it so fast that we don't even come to know. So let's see kubectl get all. It created 5 seconds ago, the other pod. Okay. So this is the declarative nature. It will always try to match the current and the desired state.